Lesson 12, Part 2. In this video, we are going to discuss what it means for a graph to be increasing, decreasing, and constant. I know we've already identified this from the graph, but in this video, we will actually define what that means. So, portions of the graph of a function can be described as either increasing, decreasing, or constant. As you travel from left to right along the graph, is the graph going up, going down, or is it remaining level? So visually, that's kind of the way you would describe increasing, decreasing, and constant. Another way to think about it is to determine what the value of y is doing as x gets bigger. So let's make a few notes. A graph is constant when it looks like a horizontal line. So in other words, like this. Another important note is that you always use parentheses when giving the intervals for increasing, decreasing, or constant. So in other words, never use brackets. And then thirdly, you always use the values from the x-axis when describing these intervals because you're describing what the value of y is doing as x gets bigger and bigger. All right, so let's look at a few examples. In example 1a, we're given this graph here. So it looks like we're going up. Then this would be constant. This would be decreasing, and this would be increasing. So it's increasing on this part of the graph and this part of the graph. So we would describe those intervals as, this interval here would be from negative infinity up to this point, and that point on the x-axis is -2. So from negative infinity to -2, the graph is increasing, and here, and the value of x there is 2, and forevermore, it is also increasing. Decreasing would be this section of the graph here. And so the values of x here are going to be, the value of x here would be 0, and the value of x there is 2. So it's decreasing from 0 to 2. And then it is constant on this section of the graph there. And so it is constant from -2 to 0. So remember, you're describing for what values of x is y going up, remaining the same, or going down. So you always use your x values here. For b, we have the graph here. It looks like if we're moving from left to right, it's going down here. And that can be confusing because the arrow's going up, but as you move from left to right, it is going down. So think of that little guy who's walking along the line. He's also going down here, isn't he? And he's also going down here. So on every value of x, y is getting smaller and smaller, sometimes more quickly than others, but it's still decreasing. So we would say it's decreasing everywhere. So from negative infinity to infinity, it is not increasing, and it is not constant anywhere.